This is Geometry, Unit 10. We're working on the volume of prisms and cylinders. So we have the volume of a solid is the number of cubic units contained in its interior. Basically, the volume is the amount of three-dimensional space that an object takes up. The volume dissection. To form a prism, you can stack two-dimensional polygons on top of each other. For instance, a stack of paper becomes a rectangular prism. Each piece of paper is a cross-section of a prism. Each cross-section has the same area. Therefore, to find the volume, you can multiply the area of the cross-section by the height of the prism. There's a video in here we could watch. We'll come back to that at the end. What two-dimensional shape can you stack up to build a cylinder? If you had a stack of pennies or quarters or dimes, you put a penny on top of each other multiple times, that would give you a whole bunch of teeny cylinders that make a big tall cylinder. To calculate the volume of a prism, our pictures here were slightly cut off. Could draw those back in, be something like that. This letter that's at the bottom is capital B, and the capital B stands for the area of the base. So the volume of a prism is the capital B times the height. The area of the base and h is considered the height. The area of the base might be a rectangle, so it's length times width. Then we times it by the height. Okay, there's the hexagonal prism. We have a hexagon for the base, rectangles for sides. You would have to find the area of the hexagon. We would do that by breaking it up into smaller pieces. A cylinder. Again, volume is base times height. Now, a cylinder always has the same exact base, and that base is going to be a circle. So the volume of a cylinder is always pi r squared times the height, where B is the area of the circle, h is the height, and r is going to be the radius. So if we come down, again, the picture's got a little cut off here. Apologize. All right, so the height of this figure is the distance between the bases. The base is the shape that's being repeated throughout the entire figure. So the triangle is being repeated continuously throughout the figure. So the height of this figure is 4. A common mistake would be to call the height 1, because that's the up and down height. But the height of a prism is the distance between the bases. We know that the volume is capital B times H. The capital B in this case happens to be a triangle, so it's going to be half the 2 legs, the multiplication of the 2 legs. So 9 times 1. Then we times that by our height, which is 4. So we have half of 36, which is 18. These should be 18 cubic feet, or feet cubed. The area of the base in this case was a triangle. So you had to find the area of the base. For the cylinder, the volume is going to be capital B times H, because that's the formula for volume. But since it's a cylinder, the capital B is pi r squared, and it's going to be pi r squared every time for a cylinder. We'll say that our height is going to be 8. So the volume is going to be pi times 5 squared times our height. So we get 200 pi, and these are meters cubed. Cubic meters. That means it's the number of boxes, 3-dimensional boxes, that would be placed inside the cylinder. Of course, it's not an exact value, just by putting cubics in there, because they don't curve to the side. You'd kind of have to melt them down. But this is considered an exact answer because we don't have a decimal. Does that make sense? This is an exact answer because we don't have a decimal. We use the symbol pi. The volume of the right cylinder. This is a right cylinder because it stands up straight. It's not slanted. And we know a cylinder is always going to be pi r squared times the height. If the volume is 1,253, we don't know what the radius is, so that's just x squared, but the height is 10. So I'm going to divide by 10 pi. That would cross the 10s out. That would cross the pi's out. I'm also going to divide by 10 pi here. You must have parentheses around them. People had troubles with that on the past quiz. So we have 1253 divided by 10 pi. So we get 3988. And that would be your x squared. Notice what would happen if we didn't have parentheses. If we said 1253 divided by 10 pi, it's going to take the 1253 divided by 10, which is 125.3, then it's going to times that by pi, and you get 393. So the parentheses make a difference. Then we can take the square root. I would suggest to take the square root of the answer of 3988. So the square root of the answer, don't just type in 39 or 39.9 or 39.88. .32. And these are centimeters because they are a length. They're not a volume. They're not the number of boxes inside the shape. On our next page, we've been talking about right prisms and cylinders. This is because the base was perpendicular to the height. Solids that are not right are called oblique. Cavaliers' principle, the three solids at the right all have the same height, the equal cross-sectional area, and Mr. Cavalieri claimed that all three solids had the same volume. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So looking here, just because a stack of pennies is straight up, or just because a stack of pennies is all wobbly, does not change what the volume is. It's not any less. It's still the same number of pennies. So when we come over here, what we don't want to get confused is thinking that the height is a slanted value. Height, remember, has to be a perpendicular value. So in this situation, as we have our cylinder, we have this 60-degree angle. We have a hypotenuse that is 18. And that alone, we won't even use the 12 for the radius or diameter. We'll just use the 18, which is the length of the hypotenuse. Because this is a 30, 60, 90 triangle, we can calculate the other two sides. In every 30, 60, 90 triangle, the hypotenuse equals the short leg times 2. So if the hypotenuse is 18, the short leg times 2 can be divided, and the short leg is going to be 9. What we've learned before is that the long leg of a 30, 60, 90 triangle equals the short leg times root 3. So our long leg, which we don't know, is the short leg 9 root 3. So the volume of the shape, the height is 9 root 3. That's the distance up and down. Pi r squared times the height. We know the diameter is 12, so the radius is 6. And the height is 9 root 3. So we'll take our 36 and times it by 9. That gives us 324 times pi times root 3. That is our exact value. Exact means no decimals, no rounding. So here it's like double exact because we didn't use a decimal for pi and we didn't use a decimal for a radical. And those would be millimeters cubed because those are cubic millimeters. The units are millimeters. The last 4 that we're working through. You spend a moment, you can pause the video, you can come back to these. How are you going to calculate the volume of a rectangular prism? So the volume of a rectangular prism, we would typically call that length times width times height. There's your base, so that would be your capital B. That's your length times your width, that's your rectangle. That's your 11 times a 4. Then your height would be perpendicular to that, which would be 5. So 220 cubic meters. That would be your volume. For a cylinder, we have learned that the base is always pi r squared, and the height is the distance between the circles, the bases. So we have 6 squared times 9. It's going to be 36 times 9. 36 times 9 is 324. And these are feet cubed, cubic feet. Here is an oblique prism, triangular prism. It's oblique because it's slanted. The value you need is going straight up and down from the highest point to the lowest. The volume is the area of the base times the height. The base in this case is a triangle, so it's half of 9 times 5. And then we times that by 8 for the height. So we could call that 9 times 40 and take half of the 40. Since it's 3-dimensionals, we have a cube written on our units. Half a length times width times height. And then to finish off our examples for today, we have our volume of a cylinder, which is pi r squared times the height. We know that our volume is 200 pi. Notice how the pi is part of the volume. Some people had troubles with this on their last quiz, when the pi is part of the answer. We can't get the diameter right away, but we can calculate for the radius. So pi r squared times a height, which is 8. We're going to divide by 8 pi, so the 8's cross off and the pi's cross off. And on this side, we do the same thing. The pi's cross off, and we get 25 equals r squared. So r is going to be the square root of 25, which is, of course, 5. And the radius is going to be 2 times 5. No, it's not. The radius, it's not what we want. We want the diameter is 2 times 5. So the diameter is 10. It's 10 centimeters.